Alright guys, welcome to lesson 2.8. We're going to continue our work with inverse trig functions, and I'm also show you a new little trick you can do when trying to integrate. It's called completing the square, which is something that should hopefully sound a little bit familiar to you from your pre-calculus. But let's go ahead and jump into our lesson for today. Now, I'm going to do this problem for you. But if you are feeling overwhelmed by the answer that I give to this problem, in our notes that I've attached for today, you can go back and look. There's a second video I've attached, which is a review video for trig. It's about 15 minutes long. If you watch that, it will help you out a little bit. But let's go ahead and see. So in the video, I worked with students to get them up to the point of being able to do this problem. And then I told them they could watch the rest of our normal lesson if they need to see the solution to this. So the first step in solving a problem like this would be to set it equal to theta. The next thing would be to rewrite it as a normal secant function rather than as the arc secant function. The next thing is we don't like secant. We like sine, cosine, or tangent. So what I'm going to do is I'm going to take the reciprocal on both sides. Because the reciprocal of secant is cosine. The next thing I would do is I would multiply the top and the bottom by the square root of 3 to rationalize it. The top becomes 3 radical 3. The bottom, these two radical 3's come together to make 3, and then the 3's cancel, so I'm left with this. And now I have cosine of theta equals radical 3 over 2. The next thing I would do is I'd look on my unit circle, and I would ask myself, what angle has an x value, because that's what cosine is. What angle has an x value of radical 3 over 2? And whenever I look on my unit circle, there are two answers, but we are only going to use one of them. The two answers on my unit circle are pi over 6 and 11 pi over 6. However, when you're dealing with arc trig functions, you're only allowed to use the top half of your unit circle, so we would not include that answer there. And the answer is pi over 6. Now, if that felt like you were drinking from a fire hydrant there, I would encourage you guys to go back and watch the second video I attached to this lesson so that you guys know how to do stuff like that, because you will be required to do things like that in today's lesson. But like I said, there is an extra little video I attached about 15 minutes long that reviews with you how to evaluate arc trig functions like that. So it's there for you if you want it. Let's go ahead and begin here, though, with the actual calculus. So example 1. So we're doing the same thing we did last time, which is we are integrating functions that result in arc trig functions. However, we're doing definite integrals today, which means we're going to be applying the fundamental theorem of calculus, where you plug in numbers and you solve it and subtract and all that good stuff. So here we go. So the first thing I'm going to do is I would look at this and I would ask myself, okay, what pattern does that seem to be fitting? Well, that fits the arc secant pattern. So according to the arc secant pattern, we would have 1 over a arc secant absolute value over a, and then plus c. But since we're doing a definite integral, we don't do plus c's, right? Now the a is the square root of 9, which is what we learned last class, so that's 3, and that goes in 2 spots. And then what goes on top here is whatever is being squared here, so in that case it's an x. Since it's an odd power, we do need to keep those absolute value bars there. That's stuff that we talked about last time. And since we've integrated, now we get rid of the integral symbol, we put brackets instead, and we move our limits over here. So far all I've done is just what we did last class, nothing new. But now we're going to go ahead and do the fundamental theorem of calculus. After you integrate, you're going to write 2 sets of brackets, and you're going to plug in your 2 limits into the expression. The one on top is what you'll plug in first. One on bottom is what you'll plug in second. Okay, so let's go ahead and simplify this now. Now, just for future notice, if you guys are doing an FRQ, this is where you would stop. If you're doing a free response test question, you would please stop there. Now, for your homework, and if you ever have a multiple choice test, you need to know how to go a little bit further. And so that's why I spent the time making the review video about how to do these kinds of things. So first of all, we're taking the absolute value of 6 and then dividing it by 3. So the absolute value of 6 is 6 divided by 3 is 2. So I'm going to rewrite this as just 2 now. Over here, we have 1/3 arcsecant of, well, if you take the absolute value of 2 radical 3, you still get 2 radical 3. It doesn't change anything. But we just did this on the last slide, right? And what did we get for our answer? I believe we got pi over 6. So I've already worked that one out for you. But now you guys get to try to work this one out, okay? So we have 1/3, and then you guys need to figure out what is arcsecant of 2. So if I were you, I would pause the video here and see if you guys can work that out really quick. And when you unpause the video, I'll show you how I get it. But definitely want to be practicing this stuff as we go. All right, so here's how I would do it. If I want to figure out what arcsecant of 2 was, I would first of all make it equal to an angle, and then I would rewrite it as a normal secant function. Then I would take the reciprocal on both sides, and I can replace this then with cosine. And so what I'm looking for is I'm looking for what angle has an x value of 1/2, and it has to come from the top half of the unit circle because we're using an arcsecant function. So what x value has a theta, what angle has an x value of 1/2 on the top half of our unit circle? And the answer is pi over 3. Okay, so now we get to do some more fun pre-algebra stuff, or not pre-algebra, pre-calculus stuff. We get to simplify this expression. Actually, simplifying this kind of is pre-algebra. It's not easy pre-algebra, but it's pre-algebra. 1 times pi is pi, 3 times 3 is 9, 1 times pi is pi, 3 times 6 is 18, and we need a common denominator. So I would multiply the top and bottom by 2, which would give me 2 pi over 18 minus 1 pi over 18. I'm going to go ahead and put a 1 there just so it looks friendlier. So now I know that 2 pi minus 1 pi is 1 pi. And there's my final answer. So don't forget to stop after the first fundamental theorem of calculus if you're doing a free response question. But for homework and multiple choice, try to take it all the way home. See if you can get there. Okay? All right, so that's that. So really, we just did what we learned last class, integrate this, and you get an arc-trig function. The only thing that makes it new and challenging is you guys have to know how to plug numbers into an arc-trig function and get an answer. So most of it's all pre-calculus stuff. So here's one for you guys. Go ahead and pause the video. Go ahead and go as far as you can with it. And when you unpause it, I will walk you guys through the process. So of course I'm going to go ahead and start walking through it. So if you haven't done it yet, make sure you pause the video and give it a try. But the first thing you're going to do is you're going to integrate this expression. Now that would be an arcsine function there. And the way arcsine works is it looks like this. You have the a on the bottom. The a is the square root of 4, which is 2. And the top is whatever's being squared there. So in that case, it's the x. And then these are my 2 limits that I'm going to put on the right side now. And then we're going to go ahead and apply the fundamental theorem of calculus, which is where you, after you integrate, you plug in the top number and the bottom number and subtract them. So it's going to be arcsine of radical 3 over 2 and arcsine of radical 2 over 2. And this is where you would stop if you had an FRQ. But for homework and multiple choice, we're going to stretch our minds and reach back into the past and try to do some of that pre-calculus trig work that we need to know how to do. So at this point, for homework and for multiple choice, I want to make sure you guys know how to do this. Here we go. So the first thing we do is we say, okay, so I want to figure out what is arc sine of radical 3 over 2. Well, the first thing I do is make it equal theta, and then I write the normal sine function instead of the arc sine function. Now for this one, it's sine. We don't need to flip over sine. We don't need to do reciprocal with sine. You only do the reciprocals if you're dealing with cosecant, secant, or cotangent. But if you have sine, cosine, or tangent, we just leave it because we already have a nice setup here. All I need to do is find what angle has a y value of this. But got to remember that when you're dealing with sine, cosecant, or tangent, you are restricted to the right half of your unit circle. So we can only use this side. Now sine is equal to radical 3 over 2, and that would be up here at that point. That's where the y value is radical 3 over 2, and that has a theta value of pi over 3. So the answer is pi over 3. Now there is another place on our unit circle on the left side that has a y value of radical 3 over 2, but once again, we don't use the left side when we're dealing with arc sine functions. So the answer for that one here comes out to be pi over 3. So if you didn't get that, I would encourage you to re-pause the video and see if you can correctly guess the answer to the next one. But the next one would be, basically I'm looking for where does sine, if I want to know if arc sine of theta, arc sine of radical 2 over 2 is equal to theta, that means that sine of theta is equal to radical 2 over 2. So we're looking for where at on the right side of our unit circle does the y value equal radical 2 over 2, and that's right here in the middle at this point. And so the angle at that point is pi over 4. So the answer is pi over 4. Then we're going to go ahead and combine these. Once again, you need to get a common denominator. So I'd multiply this side by 4. I'd multiply this one by 3. So I end up with 4 pi over 12 minus 3 pi over 12, which once I do 4 minus 3, I get 1 pi over 12 as my final answer. Okay? So there is that. Let's go ahead and move on to another topic. But that's basically it, guys. It's just knowing how to evaluate arc trig functions. Now we're going to reach back once again some more into our pre-calculus knowledge base. So once again, darn it, you guys got to remember something from the past, but thankfully Mr. Bailey's going to review it with you. It's a process called completing the square. So first of all, you could take as many notes on this as you want to, but for the first bit, it's really just kind of background information that you don't need, but you can write this stuff down if you want to. It might help you understand things better. So first of all, we need to talk about something. We need to talk about something called perfect square trinomials. Okay, a perfect square trinomial is a trinomial like this one. That can be factored. And whenever you factor it, you get the same thing twice. And since you have it twice, you can write it as a square. Okay? And so this thing here is what we would call a perfect square trinomial. Because when you factor it, you get the same thing twice, which makes it that factored squared. So it's called a perfect square trinomial. Those are useful for all kinds of things, and I'm not going to go into what they're useful for in other contexts, but for today, you're going to find that they're useful for integration, actually. It's a little trick that we can pull that helps us accomplish the task. So let's go ahead and talk about perfect square trinomials. How can you tell if something is a perfect square trinomial? Well, and once again, you don't need to necessarily write this. But it might be helpful to you. But I'll tell you when you actually want to start writing stuff down for sure, okay? But if you like the stuff, you can have it. So for instance, suppose I give you guys this, and I asked you, is this a perfect square trinomial? Well, I mean, the long way to answer that is to factor it, okay? Now, if you don't remember how to factor, there's different ways of doing it, so use whatever method you're comfortable with, but just make sure you know how to do it. Bx squared, the first term goes here, the last term goes here. You're looking for two numbers that multiply together to make x squared, and you're also looking for two numbers that multiply together to make 25. And then you know you've done it right if 5 times x and 5 times x combined, 5x plus 5x gives you the middle. If that works, then these are your factors. So how can you tell this is a perfect square trinomial? Well, because when you factor it, you get the same thing twice. But there's an easier way to tell, okay? There is an easier way to tell, and I'll share that with you right now. So for instance, instead of factoring this thing, which is a good skill to know, so I wanted to review that with you guys, but instead of factoring it, which takes a little bit of time, here's what you could do. You could take half of this. What's half of 10? It's 5. And then you could square this. Raise it to the second power. If it matches this number after you take half of it and square it, then it's a perfect square trinomial. Okay? So here's another one. Take this one, for instance. If you take half of 16, what do you get? You get negative 8. What if you square it? Negative 8 to the second power is 64. So it matches, so we're good to go. So if you could take half of the middle number and square it to get the last number, then it's a perfect square trinomial. So now this is where I would encourage you guys to start writing with me here, because this is, if you haven't been writing, this is the stuff that you're going to need to know how to do today. So I'm going to give you a problem. And here's the problem with this particular trinomial. It's not a perfect square trinomial. So step 1 is to make a perfect square trinomial. Okay, now there's a couple of steps involved. Okay, so step 1 is we're going to make a blank spot. I'll show you what I mean by that. So we're going to take our problem here. I'm going to make a blank right there and put it in parentheses, and I'm going to put the 9 over here. Okay? Matter of fact, I'm going to say make 2 blanks. We're going to put a blank over here as well in a minute. So that's your setup. So the first thing I want you guys to do is put a blank after the middle number and then put a blank after the 9 and put the 3 terms in the parentheses there, including the blank. All right. The next thing we're going to do is we're going to complete the square. And I'll just draw an arrow to this process here so you know what I'm talking about. Completing the square means I want to make this a perfect square trinomial. So what I'm going to do is I'm going to take half of the 8, and then I'm going to square that result and put it there.
I was 0.0001.
All right. Next thing is we want to subtract the value also. So let me show you what I mean by that. So after you complete the square and add a new number in, you're going to put that number over here also, but with a minus. Now, the reason we do that is because these cancel each other out, right? So why would I want to do that? Well, whenever you're doing this, you're not allowed to just add something in, because as soon as you do that, you've actually changed what the problem is. I don't want to change what this problem is. I want to just change the way it looks. So here's what I'm doing. I'm completing the square so I can get the number that I want right there. But I'm only allowed to put that number there if I subtract it over here. That way it kind of undoes it. Now, they are canceling each other out, but I'm not gonna cross them off. Okay, I'm gonna leave it just like that. So step 1, make 2 blanks. Step 2, complete the square. Step 3, subtract the value also. Now, the next thing we're gonna do is we're going to factor and subtract. Okay, so here's the subtraction part, so that's pretty easy. Let's go ahead and do that first. So 9 take away 16, what is that? That's going to be 7, right? Negative 7. But the factoring part is interesting. We want to factor this. Now, you can factor that old school style if you want to. But I have a shortcut for you guys that will always help you. It's always going to be the same, because perfect square trinomials have this little thing. They always turn out to be the same factor twice, right? So in other words, the same factor being squared, and there's always going to be an x there. So that will always be the same. The only thing that's ever going to change is what you put right here. And that will always be half of the middle number. So what's half of negative 8? It's negative 4. Okay, so I'm going to write that step here. So you always do this. And I'll put half of middle to represent half the middle term. And so this is what we call completing the square. It's a nice little strategy. You'll see what it's useful for in a minute. All right. So let's do another problem really quick, and this time we'll kind of treat it like a guided practice. So what I'll do is I will just ask you guys to take a moment and predict what each step is going to be. So here's a new problem. Let's say 12x plus 8. All right, so I want you guys to do step 1A. Do step 1A. If you need to pause the video, go ahead. Here's what you guys should have put for step 1A. You should have made 2 blanks. You should have put one here after the 12 in parentheses, and then you should have put one after the 8 as well. Go ahead and do step 1B. Pause the video if you need to. The next step would be to take half of this number, which is 6, and then you should have squared it. Now, just so you guys know, you don't have to show this green stuff whenever you do your work. You just do it mentally. I'm okay with that. But what you should have gotten here was 36. Go ahead and do step C now, 1C. Step 1C was to put the same number over here, but this time subtract it. Okay? Now go ahead and do step 2. You're going to do 2 things for step 2. You're going to subtract, and then you're also going to factor. So do both of those steps right now. Pause the video if you need to. All right, so for step 2, it always looks like this when you factor it. The only thing that's different is what number goes there. And the number that goes there is going to be half of the middle number up here, which is 12. So half of negative 12 is negative 6. And then don't forget to subtract these 2 numbers. And we end up with, what is that? If we subtract those, 28. And there you go. And so that's the process. So Just for the heck of it, if you want to, I'm going to give you one more to do, but this time I'm not going to walk you through it one by one. I'm just going to put the problem up and ask for the final answer. So I'll give you a problem, and your goal is to see if you can get to the final answer all by yourself, and then we'll start up the actual calculus portion of all this fun stuff. All right, good luck. Go ahead and see if you can complete the square and factor the problem. This is what you guys should have gotten. 5 minus 1 would be 4. There you go. All right, so hopefully you guys know how to complete the square. So why have we been reviewing this pre-calculus skill? Well, there's a lot of things that makes completing the square useful in pre-calculus, and it turns out there's something that makes it useful also in calculus. So in calculus, whenever you see an integral that looks like this, we are going to use completing the square to get the problem done. So when you have just a number on the top and a trinomial on the bottom, that's when you're going to use this strategy. Now I'm going to give you guys some steps here on the side about how we're going to do this. The first thing we're going to do is we're going to complete the square and factor. So we're going to do to the bottom of this fraction exactly what we just did on the last slide. We're going to complete the square and we're going to factor. After that, we're going to do some u substitution. And then we're going to finish the integration. From there, it should be pretty straightforward and done. Okay? All right, so step one, why don't you guys take a moment and complete the square there. Rewrite that. When we're all done, it should look something like this. All right, so pause the video if you haven't done it yet, because I'm about ready to put the answer up. If you guys completed the square correctly, you should have ended up with x minus 4, and you would also have a 4 out here, because you would have had 20, and then you would have subtracted 16 from it to get 4. So there's that. So that's the first step. The next step, after you complete the square and factor, is you're going to do some u substitution. And what do you think our u will be? Our u is whatever's in parentheses. Right, so you guys keep hearing people talk to me because I've got a class taking a test right now. But sorry about the interruptions. But anyway, so we're going to use substitution. The u is whatever's in parentheses there, right? So I'm going to say that u is equal to x minus 4. And then I'm going to take the derivative of u with respect to x, which is 1. I'm going to get the dx by itself, which is du. And then we're going to do our u substitution. So I have 3 on the top. The parentheses becomes u. And the dx, which I forgot to write, becomes du. Now, we're ready to integrate it. Now, what does that look like to you guys? What kind of integration does that look like that we've been working on for the past couple days? Well, that looks like a arctangent, doesn't it? So, the first thing I would do is I would take the 3 out because it doesn't need to be on the top when we do an arctangent rule. And then the next thing I would do is I would go ahead and do the arctangent. All right, so we have 3, and then I have my integral on the inside here. So arctangent has 1 over a, arctangent of blank over a, and my a in this case is the square root of 4, which is 2, and the thing that goes on top is whatever's being squared here, so that's my u. Now I'm going to multiply the 3 times the half, so I'm going to get 3 halves there. And then I'm going to replace the u with what u equaled. Now, if you guys don't remember, u was x minus 4. And we don't want to forget our plus c. I actually should have had that up there too. So there's my final answer. So whenever you have a number on top and a trinomial on the bottom, it's going to be a completing the square problem that results in an arctangent answer. So step 1, complete the square and factor. Step 2, do U substitution. Step 3, integrates. All right, so let's go ahead and have you guys try this problem here. Go ahead and pause the video and take it as far as you can. And when you unpause it, you'll see the solution. And there you guys go. So in step 1, that's the completed square and factored form of the same problem up above. Step 2, that's the U substitution result. Here's my work I showed for the U substitution, and here's the result of it. And then step 3, that's an arctan once again with an A value of 3. So there's our formula for doing integrations that result in arctans. And finally, we replace the U with x plus 1, right? And we end up with our final answer that you see there. So we talked about 2 things today. We talked about how to evaluate definite integrals that result in arc-trig functions. And the hard part there is do you know how to actually evaluate arc-trig functions? We also talked about how to integrate functions that look like a number on top with a trinomial on the bottom. And the secret to it is completing the square with U substitution. And that's it. So that closes us out for the day. See you next time.